part 3, single stage bridge is isolated. And you see, it still achieves 98% efficiency because it has the just simple, yeah, and I discussed, and maybe this is a good point to mention. This is what I discussed already yesterday, but in kind of a nice graphics, let's put it in color. Here is AC line, you have full bridge, then you have a boost converter. And here is also one possibility which people didn't understand. You didn't have to have shown below. Next below is a classical. You have a full bridge followed by boost converter as a PFC controller, and then generative 400 volts DC regulated line, and then from 400 volts you have isolated full bridge. Another option which is simpler, still have a boost full bridge rectifier, but followed with the boost isolated converter. Have you ever used the boost isolated converter? I don't think so, because the boost isolated converter has this inductor, and it's simpler, doesn't have this separate boost with this, and has a boost inductor, and it doesn't have the diode on the output, which is also an advantage, but this requires a special drive which uses these two switches and the other two switches to regulate. It uses them in such a way that for part of the cycle, the transformer primary is shorted. So why would you want to have a power transfer from input to output when a transformer is dead, not doing it for a good part of the cycle? So this is not efficient. But on the other hand, this shows that both of these, how do they operate as a power factor correction? You have high frequency, which generates these ripples, but average of this input current is following the sinusoidal current proportional to sinusoidal voltage. So you see this average, there is a high frequency switching, and because of boost connection, you have this property. So, and here it is, this one. And remember, we already went through it. You replace this capacitance with two capacitors in series. We discussed it when Professor Serjan mentioned what happens if the inductor is on a secondary side. Well, it doesn't matter, either on a secondary or primary. This effectively works in the same way. I can reflect this inductor to the primary inductor because it's still a good model of it. And then in this case, because this inductor is small, 2%, 1% of DC, it doesn't have a forward power transfer, but it affects dramatically the resonance. So this is PWM is not affected because PWM inductor is, 100 times bigger than this. So who cares whether you have 1% higher inductance during this period, and then during off period, you have this resonance in this loop, which is really a small 1% inductance, and PWM inductor doesn't participate. So you see the key of that switching method I introduced in 2010, you separated PWM on time versus resonant off time, and vice versa, depending on type of the converter. Okay, so here is basically what happens. And as I said, these two, and in this case, when there's magnetizing current, basically operation is the same as before. But now we have to have bridgeless PFC control, and this is the PFC regulation. So this is AC to DC, and this is what I showed you yesterday with the addition of this gallium nitride switch with the two gates. This is a simple way to provide a charger for electric cars for alternating current, changing 110 to 220 and generating 400 volt DC to charge a battery on an electric car, right? I gave it to industry 11 years ago, and have a transformer, which is through AC transformer versus forward converter, which is one bidirectional flux only, and a flyback, which is all storage and really very, very lossy and very big because it has DC storage of inductor. Okay. And what is here? This is that integrate magnetics. Okay, you can do also other tricks. We'd like cover it later. Input inductor can be integrated with transformer, and all the ripple or input inductor can be shifted to transformer. Transformer has a square wave current, so why does it carry it now? Has at the top of that some ripple added, but that input is now clean, so you don't have to have differential or EMI filter, especially if it is at 100 kilohertz. Okay, so that's number, and that's true. And this is with this bidirectional switch, as I said, using IGBT, bidirectional IGBTs. And then here is one other point. This here is voltage gain, because it operates a boost converter, so it has to start from gain 1, and then it has eventually peak magnitude, as I showed, for a boost, and comes down. So in this range, it is useful to step up, where it's used. But let's see what happened. Yeah, next.